8th grade math. This is Miss Collins, and we're going to work on this volume foldable. So I have my piece of paper. I'm going to keep it long ways. I need to fold it together so the top and the bottom are touching each other in the middle. Okay, so there's my fold. Hope you guys can see that. Now, I prefer you guys to use scissors, but I don't have any close to me, so I'm just going to tear that. Now, I have two pretty even folds. Okay, and that's how I create my foldable. Alright, so now that I've have my folds, I actually cheated. I went ahead and made one before I took this video. We're going to work on this first one, area versus volume. But we have 4 sections to cover: area versus volume, cylinders, cone, and spheres. Let's take a look at this first one. So, area is defined as the size of a surface. Volume is defined as the amount of 3D space an object occupies. I just wanted to give you guys some examples of area formulas, which is just length times width for a rectangle, side squared for a square, pi r squared for a circle, which you guys should be getting really familiar with the circle area formula. For volume, we have a capital B times H. Now, I wanted to give that to you guys because your TCAP test might have a capital B times an H for a volume formula. That is just the area of the base times the height. It's the same thing, pi r squared times H. Another volume formula is length times width times height. That's the one that we think is the most synonymous with volume. That's for the rectangular prism. Here are just some more characteristics. Area is 2-dimensional, volume is 3-dimensional, area is units squared, and volume is units cubed. And that's it for our area versus volume. Alright, so moving right along to cylinder. I'm going to open this up. I have a definition for cylinder. It is a 3D figure with straight parallel sides and circular bases. The volume formula for a cylinder is pi r squared times h. I have an example for the cylinder. 2 centimeters is my height, 3 centimeters is my radius, so I have pi r squared times height, and I just substitute those numbers in. So pi times 3 squared times 2, and that is just 18 pi centimeters cubed equals the volume, and I've left that in terms of pi, and I have my units cubed. Also, another characteristic of a cylinder is it has 2 identical flat ends that are circular or elliptical, and that's it for our cylinder. Alright, so we're moving right along to the cone. I'm going to open this up, and the definition of a cone is a 3D object with a circular flat base joined to a curved side that ends in an apex point. Now, I understand that's a little wordy, so I want you guys to just fix that however helps you best understand it. For a cone, I might just put 3D object that looks like an ice cream cone, because that's what helps me understand it. The volume formula for a cone is 1/3 times pi times r squared times h. And if you guys remember, our cone is actually just 1/3 of a cylinder. I gave you guys another example of this cone. The height is 12 centimeters, the radius is 7 centimeters, so I have volume equals 1/3 times pi times 7 squared times 12. I didn't really work that out because I ran out of paper room, to be honest. Now, some characteristics of the cone is it has a circular flat base, it's conical, It's formed by rotating a triangle around, and some real life examples are traffic cones, birthday party hats, ice cream cones, and a bird's beak on some of the birds. And that does it for the cone. All right, everyone, and our last one to go is the sphere. So I'm going to open this up. The definition of a sphere is a round solid figure with every point on its surface equidistant from its center. Now we might not be very familiar with the word equidistant. That's just a word that mathematicians shorten to be equal distance from its center. So any point on the edge of the sphere is going to be the same length away from the center. Formula for the volume of a sphere is 4/3 pi radius cubed. Or some of you all can still think that it's 2/3 of a cylinder, so we have 2/3 pi r squared h. And our h is just really 2r. And here is a really funny looking sphere, but the example is that the radius is 3 centimeters, so I have 4/3 times pi times 3 cubed. And again, I didn't really work that out because I ran out of paper room. So I misspelled perfectly, but spheres are perfectly symmetrical. They don't have any edges or vertices. And some real life examples are shape of a ball, a football, a soccer ball, a globe, or my personal favorite, the Disney World Epcot ball. And that does it for our volume foldable.